is we are going to study how we are going to develop a function structure for a particular product. We have seen some preliminary definitions in the previous class. Today we are going to see how exactly the function structure for a particular component or a product is developed. Next. Now, here we have to go for, we have talked about movement of three things. One is the flow of material, then the flow of information. What is the third?
Energy.
The flow of energy. In any product, these three flows take place. Flow of information must take place, flow of energy must take place, flow of material must take place. So how these things exactly happen, that's what we are going to see now. Next slide. Now when we talk about material, it can be a solid, it can be a liquid, or it can be a gas, or many times it can be even people. Okay, suppose you are trying to model, say, an auditorium, okay, in which you want to identify whether, suppose in our own auditorium, in the main auditorium, if the ground floor is full, then I have to stop and then send people to the balcony, right? During Orient celebrations, the ground floor got filled. Yes or no? I don't know. So I have to detect the number of people flowing in. I have to measure, and then when it crosses certain threshold, I should redirect people to the upstairs. So, movement of material can be many things. Similarly, when you model a production system, I will consider the flow of products itself. How many products are getting assembled and then flowing through? How many cars are coming out of the production system in a day? So, the flow of material, please don't think in terms of pure materials alone. It can be any units. That's what I try to emphasize here. It can be a solid, it can be a liquid, or it can be a gas. It can be human beings flowing in and out of the system, or it can be a full product itself. When you develop what is called a queuing system or things like that, you will be talking about flow of whole systems. Okay, flow of products. Next. Now, similarly, when you are talking about flow of energy, the energy can be a muscular effort. See, generally when you talk about energy, okay, whenever you talk about energy, there are two components. One is something associated with flow, and another is associated with force. Please visualize always energy as, see, what is the formula for work done? Can somebody say?
Force into displacement.
Force into displacement is work done. Okay. Work done is again a form of energy. Okay. So something, any work done or any energy will have something like a static component and something which is a flow component. Okay. Now, when you are talking about human muscular force, it can have again two components. One is the force component, the other one is the motion component. When it is sound energy, again it can have a pressure component, it can have a velocity component, particle velocity component. When you are talking about biological systems, we can talk about again pressure and volumetric flow. Again in chemical systems, chemical energy, we can talk pressure and volumetric flow. When you are talking about electrical energy, it is electromotive force or current, voltage and current. Okay. Electromagnetic forces, it can be, the examples are optical, it can be solar. So whenever you are talking about energy, it will have two components. Okay. So mechanical energy, force is one component, displacement is another component. Okay, hydraulic energy. Potential is one component, flow is another component. Potential is pressure. Okay. So that is what we wanted to emphasize in this. Next slide please. So hydraulic again, pressure and volumetric flow. Magnetic, the magnetomotive force. Then mechanical. The mechanical can be again a rotational, it can be a translational, or it can be vibrational. A pneumatic energy source, again you have to talk about pressure and mass flow. Radioactivity, again you have the intensity of radioactivity and the decay time. Decay time is going to tell you how fast or how slow the energy is released. Thermal, it is temperature and heat flow. These pairs it is better, it is worthwhile you remember because they are going to be with you forever. Okay? There is always energy is you have to view it as a twin. Energy you should always view it as a twin. Both together they constitute energy. Okay? So that sort of visualizing is essential. Go back please. Now you are talking about thermal energy means, okay, thermal energy consists of temperature and heat flow. Okay. Now you can see this you have to visualize. Okay. Now suppose there is a hot iron box. Okay. Can I just touch it with my hand with nothing happening to me? The temperature is say 400 degrees centigrade. I can just touch the iron box and nothing might happen to my finger. I can instantly touch it and take my finger, nothing will happen. How do you sense whether an iron box is hot or not? You can just touch and then take your finger. Oh, what is the idea? See, the temperature is very high, no doubt, but heat flow is very low. Because I am not holding my finger there. So the net energy transferred to my hand is low. So there is no damage to my finger. If there is a lot of energy flowing in, okay, then it will be boiling water. What is the temperature? The iron box temperature was 300 degrees centigrade. Boiling water 100 degrees centigrade, much less. Okay, if boiling water, if it falls on my, say let it not happen, but if it falls on my, say, legs, then what happens? Okay, you get boils. Why? The temperature is much lower. When I am touching the iron box, nothing is happening to me. What? Very good. It remains in contact with my skin for a longer period. It wets. The nature of water is, it holds, it sticks. Okay, iron box didn't stick to my hand. I just touched it and then in a fraction of a second, probably in milliseconds, I took my hands off. In milliseconds, I took my hands off. On the other hand, this boiling water, it got poured on my legs, but it stayed in my legs for few seconds. That is good enough because there was a lot of heat flow. A lot of energy got transferred into my skin. So they kill a lot of cells. If a lot of energy is transferred into my skin means a lot of cells got killed. So that is the reason a new skin has to grow up. Okay, the pus formation, everything happens. You understand the science behind it. You touched a much higher temperature, still escaped unhurt. Here the temperature is much lower. 300, where is 300 and where is 100? But still you got hurt. So it is not a question of just temperature. It is a question of temperature and heat. When the temperature is so high, for example, at the heart of a nuclear explosion, okay, the temperature is so high, instantaneously instantaneously means it is only a way of saying, please believe me, nothing happens instantaneously. Okay. At the heart of a nuclear bomb, okay, any material gets vaporized in a fraction of, in say, milliseconds or microseconds, because the temperature generated is so high, the temperature is so high, instantaneously within quotes. In reality, nothing happens instantaneously. Okay, in milliseconds or microseconds, the temperature is so high, things get vaporized. You understand? So, high temperature is also an issue, high heat flow is also an issue. Next slide, please. So, like this, we can visualize everything. Like this, we can visualize everything. I took the thermal as an example. Okay, the same logic is true voltage and current. The same logic is true for force and distance. Okay, energy is product of two things. Okay, they together constitute energy. This visualization must come to you. Next, then the flow definition. The signal can be status. What do you mean by status? Something is on, something is off. Okay, that tells me the status. Okay, I have a switch here. It has two states. So in which state it is, that will determine whether my voice is amplified or not. Okay, so that is an important issue in all the signal flow. Many times the status is the most widely used signal. Something is on or something is off. Something is high or something is low. So this is one important signal that we are going to talk about. Whether something is high or something is low, whether some switch is on or whether some switch is off. Then smell. Smell can be one of the signals. Okay. It can be touch. It can be taste. It can be visual. And what other things are there? It can be voltage. Many times, voltage is the most widely used signal. What we do is, in mechanical measurements, it is always easier for us to operate with voltage. Okay, I want to measure power, or I want to measure torque, I want to measure voltage, I want to measure force. I have small sensors, they are called transducers. These sensors, what they do is, they convert everything you want to measure into voltage. Because I am very comfortable handling with voltages. Voltages can be magnified, they can be amplified easily, they can be processed easily, they can be filtered, they can be processed, they can be displayed. So the moment you convert anything into voltage, it becomes easy for you to handle. Force I cannot directly display. I cannot see a force. But voltage I can immediately see it on an oscilloscope. On an oscilloscope, a voltage varying over a period of time, it can be seen. It can be magnified. If necessary, the voltage can easily be amplified. There are amplifiers available very easily. In fact, what the microphone now does is, it is amplifying electrical signal. That is called an amplifier. Why is it called an amplifier? I have a sensor here in the microphone which converts the sound wave into voltage. That voltage is amplified. Again, that electrical signal is converted into sound. This is how a simple amplifier works. So this is my transducer which converts every word of mine into an electrical signal. That electrical signal is amplified and fed back to the speaker. Please believe me, the same thing we do while dealing with mechanical measurements also. I want to measure force. How do I do it? Force, I get converted it into voltage. With voltage I can always play with. There are established systems. I have instruments to display voltage. I have instruments, systems to magnify voltage. I have facilities to record voltages. Okay. So dealing with voltage, engineers are very comfortable. So one of the signals that we are going to talk about very frequently is anything which is converted into voltage, and that voltage is taken as a signal. Okay. So mostly when we deal with these things, we convert everything into electrical pulses, into voltages. In fact, one of the research scholars working in our department, what he's trying to do is, he is trying to convert an image into a signal. An image, you are comfortable with image. Okay, you can see my face, you can see his face, differentiate, say this is Murugan, this is so and so. You are comfortable with it. But computer is not comfortable with images. Computer is only comfortable with numbers, not images. So, can I attribute a particular number to an image? So this is one of the areas of research in image processing or signal processing. So, what we are essentially trying to do is convert everything into voltage. Now, even visual data, we try to convert it into a voltage. Even visual data, we convert it into voltage. Next slide, please. Now, next. Now, there are many functions that are to be. No, you need not take down probably. Some of you can approach me. I can email it, or these details are available in the textbook. I want all of you to concentrate and listen now, because I am really rushing. I want to finish this unit today. Okay. So please listen carefully. I can send the if some of you give your email address, I can email it, or this is available in the textbook. Okay, so that's not an issue. Please listen very carefully, because I want to rush and then complete this unit today itself, because it has taken so long. Now, what is our objective? The functional decomposition of a product is our objective. A product is to perform many functions. Okay, I want to represent all these functions in a systematic way. That is what I am trying to do in this section. The functional decomposition of a product. Now, before we venture to that, before we take that task, can I generally, about any product, can I have a total list of what are the various functions that any product is supposed to perform? That will make my job much more easy, I say. Do you understand? See, what I am going to do is, I am going to take a product, I am going to functionally decompose it. Okay, suppose say I am taking a hair dryer as my product. What is it supposed to do? The hair dryer is supposed to dry my hair. The moment my hair is wet, I want to dry my hair. Okay, that is the purpose of a hair dryer. Okay, but forget about a hair dryer or an iron box or a bike or a car or a cell phone. Can you identify a list of functions that are generic, that are common to all these products? If I could have such a list, it may not be very complete, but if I could have it, then I will be very comfortable in deciding. So that is what we are trying to do now. Okay, some general categories of functions. Okay, so one is channel. What do you mean by a channel? Where have you heard this term channel before? Yes, good. So why do they call it as channel then?
The access and medium.
Beautiful. So every say if it is Sun TV, it has a particular band. Okay, particular frequency. So if you tune your TV to that particular frequency, you will be able to see that particular channel. Is it okay? If you want to see, say, NDTV, you have to tune to some other frequency, right? So, the signal is available, it is branched into different channels. Do you understand? What is coming to your TV as an input, it has a combination of all this, but that is again channelized to different TV programs, different audio and video inputs. Now, so it is a sort of branching off. So you can import something. You can import something. That is basically a channel command. You can export something. That is, importing is receiving something. Exporting is sending something. So these are all channel commands. You can transfer something. Okay. You can guide something. Okay. For example, we can transport, transmit, translate, rotate. Okay. You can allow certain degrees of freedom. You can prevent certain degrees of freedom. Okay. So here it is worthwhile, it is very interesting to note down what do you mean by allowing certain degrees of freedom. Okay. So certain degrees of freedom are restricted and certain motions are allowed. So that is also done by a gate command. For example, a piston moving inside a cylinder. Okay. A piston moving inside the cylinder. It is guided. Please remember, the piston inside the cylinder is guided. It cannot move as it likes. It can move only along the axis of the cylinder. Do you understand? So that is what we mean by guide. So import, export, transfer, guide, these are all certain channel functions. Next. Support functions. Support functions. For example, suppose say this chair, the chair in which you are sitting, this chair is supported at the legs. This chair is supported at the legs. Meaning, this chair, in this particular context, the meaning is, this chair cannot be moved in any direction. It cannot be moved in any direction. For example, this chair is also supported, but it can be moved in two directions. It can be either moved in this direction or it can be moved in another direction, or a combination of these two. Okay. This table, again it is supported. It is supported on the ground, but it can be moved with much more relative ease. It can be moved with much more relative ease because it is provided onto wheels. So these are the different types of supports. Essentially, every support, it prevents certain degrees of motion and permit certain other degrees of motion. Every support, mechanically speaking, every support, it prevents certain degrees of motion and permits certain degrees of motion. I think I have talked to you already about what is the degrees of freedom. Is it not? Okay. I have already talked to you about degrees of freedom. So every support, it essentially permits certain degrees of motion and restricts certain other degrees of motion. So it can stop, it can stabilize, it can secure. Please remember, we are not talking about mechanical systems alone. We are talking about, see, some chemical reaction may take place in my product. Okay. An electrical flow may take place inside my product. So everything needs to be reckoned. From the mechanical point of view, support means something, and from the electrical point of view, it can mean altogether different thing. So we have to be generic. That is why we are talking about stabilizing, securing, all that. Next slide, please. So connecting is again coupling. provide a couple, you connect them physically, mechanically, okay, or you can mix. If there is data, if there is signal coming from two sources, they can be mixed, okay. So these are certain other types of functions. Connecting is certain functions that are performed. Next slide please. Branching. Branching is again separating, refining, distribute, dissipate, okay, dissipate something, distribute something, refine. Please remember, all these things are essentially verbs. Simple verbs are all the commands that I have shown. You can even go to the previous one. These are simple verbs. Please remember, in functional composition or in functional decomposition of product, I am going to look for a verb noun pair. Dissipate heat. Mix water and coffee powder. Mix is the verb. What am I going to mix? Water and coffee powder. Okay. Or, okay, heat. Heat is a verb. Heat air in a hair dryer. Do you understand? Or in a water dispenser, I am going to talk about heat, water. So I am going to look for a verb which is going to perform all these functions. All that you are seeing in the list that is flowing is essentially set of verbs. So separate, refine, distribute, dissipate. Next, store, supply, extract. Next. So in controlling magnitude, you can actuate, you can regulate, you can change. I can change from one voltage to another by having a transformer. Okay, I can change from one speed to another by having a gearbox. So these are all control parameters. Next slide please. I can convert something. In the case of signals, I can sense it, I can indicate, I can sense a signal, I can indicate a signal, I can display it, I can measure it. These are all the functions I can perform with reference to a signal. Next. Beautiful. I have only 6 more slides. Or 6 plus 2, 8 more slides. Please listen carefully. I have just 15 minutes. Okay. Please listen carefully. Okay. We will try to understand it in the best way possible. As I told in the previous class, my whole functional decomposition is done in 5 steps. The whole functional decomposition is done in 5 steps. The first step is develop process descriptions as activity diagram. If you recall my previous lecture, probably you can see the first step is, am I right? The first step is develop process descriptions as activity diagrams. Now what are we trying to do in this? We have a product. The product is, to fulfill its function, the product is performing a series of processes. If you recall, the very first lecture we talked about, in the very first lecture of this course, we talked about processes and products. We have seen what is a product and what is a process. That is the core of this particular subject. Now, you have a product that is performing certain functions. To perform this function, the product has to perform different processes. What do I mean by this? Let me take an example. I have a hand dryer. For a hand dryer, what is the function of a hand dryer? To dry my hair. So to dry my hair, the hand dryer has to perform a lot of processes. What is it? It has to get the voltage from the supply. It has to convert that voltage into rotary motion of a fan. It has to again get the voltage, convert that voltage into heat, use this air to carry that heat, focus that jet of air into a I'm not giving you an exhaustive list, but all that I'm trying to impress upon you is to perform a particular product function, I am performing a series of processes. Can you identify some 3-4 processes in this example? What are the processes? Acquire voltage. Let us try to use the terms which I have listed earlier. Okay? Earlier I had a huge list of terms. Okay? So let me try to use some of the terms used there. One process that my hard drive has to do is acquire voltage. Then what it should do? Convert voltage into rotary motion. Then use this rotary motion needs to be converted into flow of air. Convert rotation to flow of air. Convert electrical energy into heat energy. Mix this heat and air. Focus it through a subsystem, nozzle, or however you call it. So, are you able to understand? A product is performing a series of processes. Now, my task will be over if I could identify all the processes that a product is performing. My concern now is I should not miss out any important process. I should manage to find all the processes that a product is performing. That is what I want to achieve. I have to find out all the processes that my product is performing. Now, how do I do this? There are basically 3 types of processes. There are basically 3 types of processes. Certain things are preparatory processes, certain things are executing processes, certain things are concluding processes. Let me take the case of the hard drive itself. Okay, acquiring the electrical energy. Is it what? Preparation, execution, or conclusion? Preparation. Do you understand? Delivering air through the nozzle, as my friend said.
Execution.
Is that delivering air? That is the concluding part. Do you understand? So every product, it will perform a lot of preparatory processes, executing processes, and concluding processes. Right. Now, first of all, what you have to do is, you have to view it as a high-level user activities. This is the crux. You have to view it as a high-level user activities, and they are networked to show a full life cycle of a product. That is, the point is, from whose perspective are you going to view all these processes? The perspective is from the user standpoint. I'll show you an example that will make it clear. You are going to stand as a user and view the product. Okay? The product characteristics are chosen in such a way that there is a well-established, clear system boundary. Okay? Then there are parallel and sequential paths which are clearly defined. There are process choices. Okay, interaction between the user and the device functions are clear. Okay, these processes are characterized using, these processes are documented using an activity diagram. Okay, next slide please. So, I have taken a simple activity diagram of a fingernail clipper. Please remember, what is the perspective? The perspective objective is that of a user. What does the user does and what is the scope? What is the scope of the activity diagram? The scope of the activity diagram, if you go back, the high level user activities are networked to show the full life cycle of the product. So what is the scope? It is the full life cycle of the product. So come back. So what do you do for a fingernail clipper? You have to purchase it, you transport it, you unpack it. You directly purchase, if there is no big transportation involved, you can directly unpack it. Okay. Then you come here, you flow through this, you come here, okay. Then you go here, you prepare to clip, you clip nails, you return from clipping. It is a loop. You prepare to clip, you perform certain preparatory functions to clip the nail, okay. You clip the nail, then you return to clip. This is one set of activities. Then prepare to file. Filing is you can file your nail also using your nail cutter. Okay, you can file your nail. I don't want to remove my nail, but I want to shape it beautifully. Then I can file it. Okay, prepare to file. Okay, or you can pick nails, return from that particular operation. Okay, so if you are filing, you file nails. If you want to pick the nails, okay, you can do that. Then while coming here, we can store it at intermediate. I can store it. That is an activity. I have to. In this case, storing doesn't require. At least I should clean it, put it in a safe place. That is an activity. Okay. So you can store it. Okay. So this is the activity diagram of a fingernail clipper. So these are the various activities. Next one. The next task is to formulate subfunctions through task listing. This is the second important step. What is the first step? You list the various activities that are performed. The second is formulate subfunctions through task listing. Now here what you are doing is using activity diagram and customer needs, a function structure for a product is formed. Now here comes the voice of the customer as an input in the design process. Now from the voice of the customer, I can arrive at a priority list of the customer expectations. For example, let us take the case of a fingernail clipper. What are the customer expectations? What do they find lacking in the present nail clippers? Okay, they don't see it fashionable, or the nail is not getting cut properly, the blade is not sharp, it requires huge amount of force, so I am not able to cut properly. So these are all the various things probably the customer would have expressed. So from the customer needs, okay, a function structure for the product is formulated. That is, you try to translate every customer need into a box. Every customer need, you try to have it as a box. Every customer need, you try to have it as a box. Okay. For example, you say it is not cutting properly. Okay. Is one of the customer need. So what should I do? I should have, okay, what the black box is supposed to ensure? proper cutting. What is my foremost task? I have to create a box. I will come back to the box later. I have to create a system. I have to create a system which ensures proper cutting of names. So, does it require any material flow? Does it require any force flow? Does it require any energy flow? That does require any signal flow. Why it is not cutting properly? It is not cutting properly because of many reasons. Probably he is not able to see. The signal is not coming correctly. When to apply the force? Okay. There is some design fault in the nail cutter. He is not able to see what is happening at the finger. Okay. So it can be due to signal flow, or the force applied is not good enough to cut the nail. So the energy flow is not good enough. In which case I have to design something which amplifies the force. Do you understand? So what I have to do is, every voice of the customer is converted into a box. These steps will become clear the moment I take up a case. Okay, right now it will be relatively abstract. Okay, keep it that way. I am going to discuss two examples that will make things clear. At least one example I will discuss today that will make things clear. So every voice of the customer is converted into a function structure. So the function structures are defined as an input-output model, as a black box. Okay, something which cuts properly. So whatever the input I can evaluate. If the signal is wrong, I can amplify the signal. If the force is short, if the force is not enough, I can amplify the force. I can do. You identify the primary flows associated with the customer needs. There can be many customer needs. In a particular customer need, what is the primary flow? Every customer need is converted into a flow. Every customer need is to be converted into a flow, meaning input, output. If the flows cannot be conceived, it is satisfied through constraints. See, certain flows, it cannot be constructed as an input-output. For example, a customer wants a compact nail cutter, so that he can always put it inside his purse or a wallet or whatever it is. He can always carry it. So compactness, or a customer wants a cheap nail cutter. Please remember, we have always seen two categories. One is a function, the other one is a constraint. What cannot be viewed as a function, you treat it as a constraint. Okay. So certain flows cannot be conceived, they are to be viewed as constraints. Cost cannot be viewed into a single process. All the parts taken together constitute the cost. So constraint, you take cost as a constraint rather than a function. Next slide please. Now we have come to the third step. In the third step, what you are going to do is put all these together. Put all these voices of the customers which were converted into flows. The voice of the customer was converted into a flow that you put together. That is the aggregation part. That is the third step. Next slide please. Now validate the functionality evaluation. This step is very, very important. You validate. When you put everything together, you check very thoroughly whether it works in the intended fashion. You wanted something to happen, you really check whether that is happening. Next slide. Now you, as an output of functional decomposition, there are two things that are outputs. That is the product architecture and the how it is assembled. Essentially, both mean a similar thing. How the product is structured, that is an output of your product identity. Okay, so you talk about the product architecture, how it is structured, and what are the various assemblies and sub-assemblies. That is the output of this functional decomposition. I'll take one product, just another 5 minutes, please listen carefully. We will call it a day then. Now, it is an electrical pencil sharpener. You have an electrical pencil sharpener. So there must be something like your sharpener, but on switching on, either the sharpener must rotate or the pencil must rotate. There must be relative motion between the two so that it gets on. There are many important things that you have to see. Now, electricity, please see. Okay, these are dotted lines indicating what? Dotted lines indicate what?
Information.
Flow of signal, information. Solid lines, thick lines,
Material.
and normal lines, energy. So electricity is coming. You are importing electricity. How do I import electricity? From the mains. I take the electricity. Then you actuate electricity. Then you convert electricity into rotation. Okay. This rotational energy is changed. What do you mean by change? I may have to increase or decrease the speed, and it is given here. Is it okay? Now let me see here. This is where the pencil comes. But the pencil will not come automatically. Pencil, I have to take the pencil and put it to the sharpener. So you have the hand here. Okay. Hand, it is importing human force. Where does my hand import the human force? From the muscle, it takes the human force. Okay. Then hand comes here, hand goes here. Unhindered. Every time I sharpen my pencil, I want my hand to be intact. So material as a material, it enters and then it leaves. Then this human force alone is used to take the pencil, import solid. That pencil, I have to sense. Whether I have really gripped the pencil. After I'm gripping the pencil only, I should actuate. This is the flow of signal. I should actuate. It is switching on, switching off. It is a signal. Then I gain the solid. Then that rotary motion is applied onto the solid. Okay. Now you separate solid. Now you can see here there are two parallel processes taking place. There are two parallel processes taking place here. One is to the pencil, the other one is the wooden shavings. So the pencil is exported out, the wooden shavings are again guided, they are stored, they are to be disposed of, again exported. Okay. Now there is, when I convert the electrical energy into rotary motion, there is some vibration. The vibration comes out as an energy out. That energy out needs to be minimized, dissipated. That is why that is marked again. Similarly, when this sharpener is working on the pencil, there is a noise generated. That is again coming out as, that is again coming out as a energy flow. So there is a noise coming, that noise is an energy out again. Okay. So when the pencil comes out, the pencil is coming out at a level. So it possesses certain energy. That is why there is an energy line indicating gravity. If the pencil is dropped, it will fall to the ground. It needs to be safely transported. So the higher energy level is indicated by gravity. You have a material also flowing in there. a sharp pencil. Okay. Now here what you have is a complete description of all material flow, energy flow and taking place in the case of a pencil getting sharp. This is available in your textbook. Please go through this and then come for the next class. Probably I will spend some 10-15 minutes in discussing this because it's already getting late. I will discuss 10-15 minutes discussing one more example and then we will finish off the functional description. We will move on to some other thing. Is it okay? I'm sorry for the delay.